Hi, welcome back. This is Professor James Canavan, and I would like to point out that in computer science, sometimes we are faced with having to do some mathematics towards defining a problem. And this can really mess up some introductory computer science students who are just trying to struggle with the syntax because this falls in the level of mathematical reasoning. And in this case, we're really lucky that the writer of this code has done this ahead of time and that we can use. Basically, what he provides is four equations that we can manipulate and make this idea of where to place the aliens really quick. Okay, so that's what we're going to look at. This is mathematics. You just kick back. And by understanding this, you'll see how we are dealing with movement and placement, and it really will help and clear things up. So, how do we figure out where the aliens go when we put them on the screen? Okay? So, first off, let's go with what we know. We set the screen width to be settings.screenWidth when we created our game instance. And then let's figure, okay, we got an alien, it has a particular width. Let's have a margin of that width on the left and right hand side. Okay, and so if we take the screen setting width, which we know, and we minus out that amount for the margin, we will get the available space in the X direction, that's left and right, that we have. This is our gameplay. This is our gaming place. Okay? So that's our horizontal space. So we can set up a margin. Now again, this is in reference to the point 0, 0, which is in the upper left-hand corner of our screen, where if we go to the right, that's an X positive direction. If we go down, that is a positive Y direction. So everything is in relationship with that, but we know where the screen we are. So let's place an alien, particular width and height, which we don't care about. It doesn't matter. It's part of the object of the alien. And let's think, okay, let's put the space between each alien to be another alien. Okay, so this defines a bounding box, which is defined for one alien, all right, within the horizontal space. And then the number of aliens that I can put from horizontally would be the available space, which we have, divided by 2 aliens width, because that's what it is for each alien, okay? And this value of double is good old Python's way of giving us a floor division, and we can drop the remainder because we want to be, these are integer values. We don't want a fraction of an alien. So we write out the number of aliens because we know how many we have and can put there. We write them out, and we get to the end. And now that we have a row of aliens, we want to know how many rows we can have within our game space, right? So the availability of space from the top to the bottom will be the screen height, which we have already defined in the settings class. And so let's figure this out. So we got the setting screen height, which is right here. Get that. And let's figure the height of our ship, right? Because we don't want to place them, so low, right? So the height of our ship is what we want to minus out from this, the height settings. Then let's put an alien, and let's put another alien space just to be for like a space so we can move around in here, all right? And at the top, we will have another alien height to just give a margin at the top, right? So we have some space up here at the top. Okay, so that'll be that amount. We'll line it, and let me move the alien row up there. Okay, so that's our first row of aliens, all right, within this space. Now, we know the available height that we have our working for. So we can use that to figure out how many rows we can have. Now, I'm assigning here a margin or space between each row of alien to be the height of the alien. Okay, so we have one alien and another alien. That's two aliens. So the available space between these lines here will be divided, and this is for the y direction, would be divided by 2 times the alien height. Okay, so that's the space, and let's draw another row. So we calculate the space, and we draw another row. Okay, so we probably can't get, there's only that space right here, we probably can't get another one in there, but that gives us the number of rows of aliens that we would have. All of this, these placements of all these in a loop, come from the 0, 0 position in the upper left-hand corner. So within these calculations for each, like one here and here and here, the upper left-hand corner is going to be placed, each one will be placed individually. So the first one and the second one, all the way down the row, without going into what these calculations are, but these are calculated in a loop upon each individual alien of the aliens group, plural, right? And then it goes down to the next row and does the same thing all the way across, the next row all the way across. So we've written out our aliens here, and we've placed them, and there they are. Now, what's really unique that we should notice about this method of using these 4 equations is that this whole placement scheme is independent of the size of the screen, the width and the height. It is also independent of the height of our ship. So we could change the ship out, and the placement would change also. It is lastly independent of the width and height of an alien. So we could make smaller aliens or bigger aliens, and this placement scheme will work. Now, again, this is kind of the dirty side of, the messy side, not the dirty. It's not really dirty, but it sure is messy side of computer science that is not really Python. This has nothing to do with Python. This is some extraneous mathematical calculations, which really can be a difficult thing when you're trying to apply a new programming language, especially when you're trying to learn the syntax. Okay, this will simplify a lot. When we see these 4 equations and we program these, we won't have to explain them at this point. Okay, I'll see you in the code. Thank you so much.